An introduction to AMT synchronizer. To test synchronizer relays, AMT synchronizer room can be used. The synchronizer is a piece of equipment that is used to connect the generator to the grid that is being used and uses the voltage of both sides to examine the state of frequency and voltage, and if the difference between the generator voltage range and frequency and the grid is less than the specified limit, the connect command is issued. If the mentioned difference is more than the specified limit, the relay will not issue the command for the connection. In this case, the relay examines the generator frequency and voltage state compared to the grid. If any of these two parameters is lower or higher than the specified limit, the relay synchronizes the two systems by giving the command for an increase or decrease in the AVR and the governor. The synchronizer room has several pages and exclusive windows. The two main windows of this room are test view and synchronizer characteristic. The short test and synchronizer test are done in test view window. To perform a short test in this room, like the other rooms, the user only needs to specify a test point and perform the test. Also, the performance of the relay in synchronizing the two systems is tested in Synchronizer tab. The synchronizer characteristic is displayed in the synchronizer characteristic in accordance with the information entered in the test object of this room. The tools available by right-clicking or left-clicking in this window and the cog at the bottom are common in all rooms. To enter the relay information for the test, the first thing is to enter the nominal information of the relaying device. In this section, it is necessary to enter characteristics such as PT turns ratio and frequency. In the next step, the relay characteristics are entered after double-clicking on Synchronizer. Since these relays use voltage in Protection Device tab, it is necessary to select the sequence of phases and phases that are connected to the relay in rotation sense, and connected voltages for systems 1 and 2. Note that system number 1 is an infinite bus and system number 2 is a generator that needs to be connected to the grid. An important point is that when the system phases are wired as ACB, it is necessary to select L1, L3, L2 radio button. Also, if connected voltage on any of the phase to ground states is selected, the voltages of systems 1 and 2 are displayed in test view in form of phase to ground. The key performance time is entered in the settings section of this part and in the CB closing time field, and the phase shift that can come from intermediate equipment or a coupling transformer is specified in transformer group phase shift. The nominal voltage of the system number 2 is entered in VNOM LL field, and if this value is different from that of the system number 1, it needs to be specified. By specifying this value, the voltage difference that is resulted from the test will be in relation to nominal voltage of system number 2 and not the voltage of system number 1. This means that if the nominal voltage of system number 1 is 110 volts and the nominal voltage of system number 2 is 100 volts, and the allowed difference of these systems is specified to be 2 volts, the minimum and maximum voltage of system number 2 must be 98 and 102 volts respectively. When the PT secondary turns ratio of the grid and the generator are the same, use ratio of system 1 is to be used. For example, if the PT turns ratio of the grid is 400 kilovolts to 110 volts and the turns ratio of the generator is 15.75 kilovolts to 100 volts, since the secondary turns ratio of the two systems is not the same, the user needs to enter the PT secondary voltage of the generator or system number 2 in the VNOM LL field. The characteristic related to the relay is entered in synchronizing window. The characteristic entered in this section needs to be in accordance with the relay settings. The upper and lower limits of voltage difference and the upper and lower limits of frequency difference are entered in delta V once bigger, delta V once smaller, delta F once bigger, and delta F once bigger fields, respectively. The relays mostly tend to issue a connect command in the dead zone range that is located between delta F min and delta F max parameters. The allowed angle difference of the system number 2 is entered in delta phenom field and is entered in delta phi. For example, if the nominal angle of system number 2 is 30 degrees and the allowed difference is 20 degrees, by going to vector view window, the user can see that the allowed connection range is determined to be between 10 to 50 degrees. Also, the allowed tolerances for different parameters and the minimum allowed connection time are entered in the fields on the right side. About the voltage that is being used for the test, it should be noted that the relays measure the applied voltage, and if the nominal voltage is as much as 110, the user only needs to apply VLE and VL2E for systems number 1 and 2 with the same value to the relay, and this can be viewed in the hardware configuration. For example, if in the protection device, in the connected voltage tab, the two systems are set at L1, L2 mode, by going to the hardware configuration window and in the analog output section, it can be seen that considering the selected mode, two sources are specified for the voltage that is being used for the test, and that in fact, VL1E plays the same role as VL1L2 of system number 1, and VL2E plays the same role as VL1L2 of system number 2. To better understand this, suppose that 110 volts line-to-line voltage is used for system number 1 and for system number 2. A 63.5 volts VL1E phase voltage is used. To enter the information of such a system, it is necessary to enter L1, L2 and L1E as connected voltage for systems number 1 and 2 respectively. Also, 63.5 times square root of 3 or 110 volts is entered as the VNOM LL for system number 2. Now, by opening the test view and vector view pages, it can be seen that 63.5 and 110 volts are entered as the nominal voltage for systems number 2 and 1 respectively. The next point is that only for system number 1 it's possible to select a three-phase voltage because only the voltage group A of the device is three-phase, and as for system number 2, it is only possible to select a single phase or line-to-line voltage.